How's it going, everybody? My name is Jim, and welcome to Restoration Projects. This video is going to be more of a technical, in-depth look at what goes into rebuilding one of these 6x48-inch Rockwell Delta belt sanders. So I put this video out, I think about a year ago, and I just did a lot of music to it, time-lapse, didn't really go into a lot of the specifics. So what I'm going to do is a voiceover of that same video. I'm going to try to slow down some of the clips here so I can go into a little bit of detail on what it takes to rebuild these. Now, starting off on the history of these, the earliest documentation I found of these was in 1936. It's a flyer that I found on vintagemachinery.org. And looking around, these were produced all the way up until the mid-2000s, I believe. They fell in and out of production as Delta was bought and sold by different companies. Now, as far as the rebuild itself, this was one of the more challenging rebuilds I've had to do because these aren't very common. You don't see them pop up on Craigslist or Facebook Marketplace that often. And because they're a little more rare, finding parts on eBay is next to impossible, especially for some of the more common parts that wear out on these, such as the top cover that goes over the sanding drum. Now, up until this point, everything came apart off the machine really easily. Simple nuts and bolts, very self-explanatory. Now on this side here, you have the lower drive unit, and you can see there are two different wheels that are on this shaft, and that nut on the end of the shaft pushes those drive wheels together. They're forced up against a shoulder on that drive shaft. Took a little bit of finagling. That inner wheel there, I had to use some WD-40 to get it to come off. I wouldn't call it a press fit on there, but it was pretty darn tight, and there was some corrosion as this machine sat outside for a while. Right there, you can see me pulling off the string. That came off some sanding belts, I'm assuming, or just got sucked up into that shaft over time. Now, the way that these come apart is there's two nuts there that you see me pulling off the back side, and then that brings off that arm. So you have to pull off the drive rollers before you can take the arm off. And there was just a lot of dirt and debris in there that I was vacuuming out. Now, getting this nut off, this is where the challenges started. That's a 1-inch nut, and I tried with a crescent wrench, I tried heat, WD-40, I could not get that thing to budge. It was just a royal pain. So I bought a deep socket, 1-inch socket there, took over my bandsaw, and I cut it in half. Then I got a piece of pipe that was roughly the same diameter. There it is. And I'm going to cut that one too, because that long socket would not go all the way down the shaft, so I'm having to make that socket longer. So I've taken the 3 pieces here, the 2 parts of the socket and the middle part there, and I'm welding them all together. So this will give me a really long socket that I can get down on there and get that nut off without stripping it out, because I was starting to mar it over when I was using the crescent wrench. So there's the whole setup. You can see the long socket there, hook up the impact gun, and anticlimactically enough, it came right off. So I don't know if I had put enough WD-40 on over time or if that's just what it needed. Now there are 2 bearings that support the lower drive shaft. I was able to bang the one out that stayed in the cast iron housing there, and the other one that stayed on the shaft, I was able to take a piece of square tubing, support the bearing, and hammer the shaft off of it. They're pressed on fits, and those bearings usually go out because they're under a lot of force, and they're in a pretty hostile environment because there's a lot of all that grinding dust falls off and can get into them. Now that we have everything painted, we're reassembling. So there's 3 bolts right here that hold that lower cast iron housing to the base, and we're getting ready to install the bearing. So cleaning out the housing there, and there are the bearings. I took the shaft and I froze it. That way it would shrink down just a bit to make it easier to press on those bearings. A little bit of WD-40, that helped get it on. And we're installing the one side there. So it takes a little bit of force, and this is just a little bit more finagling than what's typical of your, say, bandsaw or drill press bearing replacement. Now on this side here, putting the bearing in, tapping it into that housing, and you're kind of fighting yourself going back and forth trying to get those 2 bearings to get all the way in. Now I was having trouble seating the one bearing on the side, so I'm using the drive wheels there, and I'm using that to push that bearing in using those drive wheels, because as those drive wheels are being tightened with that nut, it forced the bearing in. Now that I have the bearings in place, I can put on the bearing retaining nut, and this is where I ran into some trouble. If you watch closely here, you'll see me using a chisel to tap on the nut here because it's designed for a spanner wrench. And what I mistakenly did is I cross-threaded this. I thought I was just going through a tough spot in the threads there, but that was cross-threading right there. So learn from my mistakes. Don't do this. Clean up your threads before you put them on. If you're running into trouble like that, don't cross-thread it. It's not nature's Loctite. It's just screwing up your machine. Once I have that on, now I put the arm on. The arm just held on there with those 2 bolts. And those 2 bolts are what you loosen to adjust the belt from horizontal to vertical sanding position. Now we've moved on to the table. We're just installing the support bracket there. It's 3 bolts. And now we're going to get ready to install this onto the machine. And that table is held on with just 1 bolt nut. Now I'm getting ready to put on this top idler pulley. So this one I did not have to do anything to. I didn't have to adjust the bearings or anything because they were doing just fine. One thing to note about the top idler pulley for the belt tracks on is sometimes they start to lose their crown. So they have a crown on them, so they're higher in the middle than they are on the edges. And this keeps that belt tracking centered down the middle. And what will happen over time is those will wear out and they'll become flat. So that's another issue with these sanders. A trick that I've learned watching some forums online is you can take duct tape and just run a couple passes over the middle of that wheel, and that will create a high spot which will mimic that from the factory high spot. What you see me doing right here on this lathe is I am making a handle. So this is a height adjustment handle. So I'm just tapering down one end. I've taken it over to the mill where I am drilling a hole in it to set a set screw. So this handle, or knob I should say, is what I'm going to use to adjust the height of the top idler pulley. So now we're just going to tap in here, and this will just be for a grub screw to go into. These replacement knobs or handles are the most common thing that I replace on a lot of these machines that I'm doing these restorations on. Just having some bar stock on hand, so aluminum and brass, comes in really handy to manufacture these parts on. So there we are, just facing it off, putting in a live center point there, and we're just going over it with a knurling tool. So you can see a lot of this is my older machinery that I had. So this is my old 9-inch South Bend lathe, and you'll notice that that mill that I was using earlier was a Harbor Freight small round column mill. So there's a finished product right there, and really happy with how that came out, especially on that old lathe. It did great work. Those little 9-inch South Bends are amazing. So now that we have that done, we're going to put that grub screw in, and I'm going to attach it right there on the front. And that is the knob that adjusts the height of this. So you can see right there going up and down. Now I'm putting on the guards. There's the back plate that came with this. And 2 parts that I had to get off eBay was a platen, so the part that is behind the belt that you press up against. So the one that came with this, because this was built in I think the 70s, this was a plate steel that was welded together, and plate steel will bend when you press up against it. So what they found out that would happen is when you press up against that platen that was plate steel, it would track the belt off of the pulleys. So they eventually went back to the cast iron that was the original design back in the 40s. And I was reading somewhere that when they went to these stamp steel or the plate steel platens, after they went back to the cast iron, they would actually exchange those obsolete plate steel platens for free for a cast iron one afterwards, because they learned, that wasn't a good design. So that was just part of the downfall of Delta. When Rockwell took over, they tried cutting cost by, making things cheaper, and that was a side effect of it. Here is the motor that we're putting on here. That's a 3 horsepower motor from Harbor Freight. Is that a little overkill? Yeah. Is it worth it? Yeah. So we're just doing an install here. I'll give you a quick rundown of the parts that I had to replace on this. So the side plate cover, it was missing that. The platen I had to replace. Part of the lifting mechanism, so it was broken. I had to find a top cover that went over the belt guard, or the top belt guard cover. All these things added up. So this project got expensive really fast. So just know that going into this, that if you're looking into rebuilding one of these, if they're missing parts, those parts are not cheap to find, and good luck. Because these things were not super common, and there's not a bunch of people out there who have parted these out to put them out on eBay. So this is a finished product right here. I just have a piece of maple there that I'm running over some 60 grit sandpaper, and it is hogging that material off. I was really happy with it, that it would really take off a lot of material really fast. So these are awesome sanders. If you need to move material, this is how you do it. Having a capable motor is important. And you'll notice there's no guard over the top belt. Like I said, I found that, I think, almost a year later. I mean, it took me a long time of hunting on eBay, and they just do not come up that often, and when they do, they're a couple $100. So just be prepared to pay the price for one of these machines. So yeah, overall this is a fun build, but it was challenging because I had to source parts, and it was just finicky to get everything working properly and get it back together right. Because I had to put a piece of duct tape, like I said, over the top drive pulley there to keep that belt from tracking off of it because it was wore out. So there's a lot of parts on these things that do wear out fast, and I would rate this as one of the more complicated restorations I've had to do. You can see right there, that's a piece of cedar, and with that dust collection that was hooked up to a 2 horsepower dust collector, it didn't make any dust in the shop. It just sucked it right on down. So that's the overview of what went into building this. Here's a couple of photos of when I did finally finish it and get that top belt guard right there. You can see it's on there. That's the original color, matches the bottom dust chute color. And this is a fun build. Definitely a lot more complicated than like a bandsaw or drill press. A lot more finicky to get dialed in. But overall, had a lot of fun. Hopefully this gave you guys some value. I know there's a lot of comments asking for more details about what went into this build, so hopefully I provided that to you in this video. If I did, please hit that subscribe button, hit that like button. It really helps the channel out. Thanks for watching.